third project assignment of the course, the foundation design of the tall building. This is the planned foundation. Here you can see there are 16 columns which are 6 meters apart from each other. The outer columns are of 500 by 500 size and the middle columns are of 600 by 600 sizes. This is C1 column, C2, C3, C4. This is C5, C6, C7, C8, C9, C10, C11, C12, C13, C14, C15, C16. So now we will look at the software and how it will be drawn and assign the properties. I have already drawn and assigned the properties, but I will tell you how to do this in very short detail. From the file menu you can select new model and draw the geometry of the section. You can define the coordinates in X and Y. You have to select 19, which is 18 plus 1, so 19 will be in X direction and Y direction. The spacing will be 1 meter each. Then make sure you select the IS code 456 and the units, metric units, and the template should be grids only, and the grid data can be assigned to them. The grid will be drawn by default, so you have to then define the properties, material properties, M40 concrete and HYSD rebar material. So I have already added them. You can modify or show material. You can note down the property data. Here it is. It's 25. The modular velocity, Poisson ratio, coefficient of thermal expansion, shear modulus, 40. Okay. The HYSD, you can check the details. Material, it's 77. The detail is okay. The modular velocity, yield stress, and the minimum tensile stress. Okay. Now you will define the slab property. Here it is mat footing, so it is already I have earlier. You can change you should make sure you select the mat. Okay, type mat footing. Okay, and column properties. Here two types of columns are there. Show the column 1 properties and column 2 properties, the dimension and the rectangular M40 concrete they selected. Okay, M2 will be column 2, the 600 by 600. Okay, then define the load pattern and load cases, dead and live load. Here dead and live load combination you have set combination 1 and combination 2. Combination 1 is for the strength, ultimate strength, where scale factor is 1.5 for both. The combination 2 is for service, the scale factor is 1 for both. Make sure you select all three. Then you have to draw the column, slab areas, the slab areas, column, design strip, make sure you set the data accordingly. I have already drawn the strip area and by the given data. So the strip width will be L minimum by 4. The formula is L minimum by 4. So L minimum is 18 by 4, it comes 4.5 meters. So we have taken 4 values, so you have to edit the values 4 in all this and draw the strip A. This is the middle strip, design strip A. Likewise you have to design mid strip B. Design strips, here you can select B, and the data will also be the 4 meter on all these width size. Here I have drawn the width design strip. These are all of 4 meter. Then you have to assign the properties to them. You have to define the soil subgrade property also. Soil 1 modified. Here the subgrade modulus K value, the formula for it is safe bearing capacity upon the total allowable settlement. Here in this case we have taken 300. The safe bearing capacity and allowable settlement is 1 centimeter, so the K value comes 3 into 10 power 4 kilonewton per meter cube. So make sure you set the value accordingly. Then you have to assign the load to all these elements. For this footing, you should select the footing areas. Footing area and select the footing area and assign the property here to footing columns. And after assigning the properties, you have to assign the load to each column. These are the column data. For C1 column, the dimension is 500 by 500. Dead load, live load. For C2, C3, C8. Likewise, you can for C9 to C16, these are the dead and live loads. You can check by clicking at the center point. The load data, point load. Here the load data are shown. You can select dead or live. MX, the dead dimension here you have to set 500 by 500, and the gravity load, which is you have to set. Here you can see the dead and live loads on each column by selecting them. Suppose you have to check for column C5, so C5 column is here, it is C5. You can select it and check whether the load is assigned. Here is the dead loads. The values are shown 500 by 500 dimension. Check accordingly. For C8, C5, C6, C7, C8 is equal. So C7, we can check for C7 accordingly. The dimension is 600 by 600 and the loads are properly assigned. You can also check for the design strip whether third rebar material is assigned to all of them. It is strip B. HYSD bar should be rebar material for all the column as well as this design. After assigning the load values to individual column, And after assigning the properties and checking whether the strip and the load and whether the rebar material is HYSD for all the elements, we will now run the analysis. Run analysis option. The analysis results will be shown. The values are indicating according to the color. You can also hover the cursor and show get the values accordingly. After that, you can run analysis and run design option. In display option, the punching shear will be shown. Punching shear design. Here you can see some values are greater than 1, and here it is showing failed option for the values which are greater than 1, and for which is value is not showing any. So we have to modify the slab properties to get the punching shear values less than 1. So we will unlock the model. It will delete the analysis and design results. Okay. Slab properties, modify. Suppose we increase the thickness to 1200 mm. Now we can run design again, run analysis. The displacement values are shown again. You can see the punching shear design option is not highlighted because you have not run the analysis and design. So if you will not run the analysis and design, the punching shear value will not be shown. So you have to run the analysis and design, then the punching shear design will be shown. So now you can see all the values are less than 1, so it is okay, and it is safe to design the foundation. All values are less than 1. You can see the slab forces by selecting the combination loads. The forces will be shown here accordingly. Vmax, the shear forces will be shown. To go back to the undeformed shape option, go to display, show undeformed shape. Reaction forces, slab forces, stresses, crack widths can also be shown from these options. After that, you have to run analysis and detail. Run detailing. Make sure you select all these. The detailing result is shown here. You can get the all components of detailing. The framing plan, rebar table, rebar schedule, bill of quantities here are shown. Just click on this and get the result. You can use pen option and zoom it to show the results. Rebar table, rebar schedule. You can also see the drawing sheets, list of drawing, and here is display here. Beam curtailment plan, individual slab views, section 1, section 2, rebar top plan accordingly. To go back to the undeformed shape. Click here and show undeformed shape. You have to check whether the status is okay for all the columns. You can check here, show tables, concrete design. Just click and click OK. The shear and flexural shear data will be shown. Here you can see the status text for all, it is okay. This means the design is okay and safe. Click on the done option. So this was the project. Thank you.